first lesson, we're going to be talking about something that's a little bit awkward that you don't use very often. The last time I saw this when I was when I was taking a logic class in college, but you don't see this very often in a traditional like algebra course. But we're going to see a lot of different new notation, and that's why you're going to have lots of, I guess, new vocabulary here that we'll be looking at. So the two learning targets for today's lesson: number one, being able to use this stuff called set notation, and then number two, determine the union and intersection of sets. And so lots of tie-ins to logic here. All right, so here's a lot of vocabulary. So what is a set? A set is basically just a collection of objects. And so typically the way that we will write set notation or have a set or a collection of set, we usually use a capital letter to indicate which set is which, and then inside the set will just be a set of numbers, so to speak. So it could be anything. It could be a finite set like 3, 5, 7. Or you could say something like B, and then you'd say X such that X is odd. And obviously that would be an example of an infinite set. So we can have finite sets that are limited or infinite sets. And they can both be written here. Typically with a finite set, they'll all be listed out. And then if they're an infinite set, they'll be listed this way. A couple other specific things. The null set. What is the null set? Well, the null set is a set of nothing. Nothing. It's the empty set, is actually another way of putting it. And typically what we would do here to express that, you would either have 0 with a line through it, or you would have a set of brackets that's just empty, hence the empty set. Please don't combine the two. That would not be correct. Please do not write the null set of empty. So this is not okay. All right, so if the null set is the empty set, it's void of any objects, the universal set would be the set of every object. And it doesn't necessarily have to be like every real number. Don't be thinking like that. It's just you're starting out with a set of numbers, and maybe you have some other sets that you're working with that are partial to that universal set, that the universal set is kind of the original thing that you're working with. A subset. So when we're talking about a subset kind of has a special symbol to it. So it looks like that. That's the symbol for subset. And we would say something is a subset of another set if everything in that original set is in the other set. So I might say something like 3 is a subset of odd numbers. Okay, because 3 is in the set of odd numbers. All right, and now kind of moving over to some other things. So complement. Complement is everything else, for lack of a better way to put it. And so if the universal set is everything that's in that kind of thing that you're working with, well, the complement would be everything else. So I guess a real quick example. If I had maybe a universal set of maybe 1, 2, and 3, and then I had maybe another set, call it set A, and that was a set, and it just had 1 in it. The complement, and the way that we would say that would be A prime is the indicator. A prime, everything that's not in set A that's in the universal set, well, that would be all the rest of the stuff. It would be 2 and 3. All right, disjoint. Now we're getting into more of the second learning target with union and intersection. Disjoint, so I guess if we had 2 sets and they were considered disjoint, there are 2 sets that have absolutely nothing in common. Okay. So, like for instance, the set of odd numbers and the set of even numbers would be considered disjoint. They have nothing in common. But then we have 2 other things. We have intersection and union. I guess before we start in on that, it might be easiest to think of like Venn diagrams when we talk about this stuff. And so disjoint would be like, here's 2 sets and they have nothing in common. You can see that there's no overlap. The intersection of sets has a special symbol. And so if we had 2 sets, column A and B, the intersection of 2 sets would be this symbol right here, like an upside down U. We'll use U for union. That's an easy one to remember. And so intersection is just the other one. So the intersection of A and B would just be the things, or the objects that they have in common. And so that's just pretty easy to look at. All right, they both have these numbers in common. That would be the intersection of these sets. And then the union, that's got a special symbol. We just talked about that. That's the kind of big U. So the union of A and B, well, that would simply be everything, every object of both. Right? So just include everything. And if it doubles up, you don't have to write it twice. But if it says it once, it's on there, even if it's not in the other. All right, so some quick examples here. Number 1, identify the set as infinite or finite, and then is 10 in that set. So we have something here. It says x, such that x is a natural number. If you don't remember natural numbers, those are numbers that you can count on your fingers, starting at 1 and then 2, 3, 4, all the way up to infinity, I guess. So x is a natural number greater than or equal to 10. Well, we start at 10, 11, 12, 13, 14, 15, 16, and so on. And it never stops. So this is an infinite set. And is 10 in the set? Well, it says greater than or equal to 10, and so 10 is or equal to, and so yes, 10 is in the set. All right, true or false? 12 is in the set of 20, 18, 16, 14, and 12, and 10. And, well, you see it right here. And so, yes, it is. And then we have a set. Is this a subset of the other one? Well, is each one of these inside here? Well, yep, we see 2 here, we see 5 here, we see 7 here, and we see 9 here. This is a subset of the bigger one, and well, it gives us something no, it says not a subset, so this one is false. I guess this one is true, not yes. All right, and then here is the null set. In the set of natural numbers. Well, true. The null set, nothing is in every set. So, all right, and then lastly, here we have the universal set. In this case, it's just 2 through 7, and then we've got 2 subsets, A and B. Well, the union of A and B would just be everything that's on there. And so we'll just kind of re-list all of this out. We've got 1, 2, 3. We have 3 again over there, but we don't need to write it again. We'll just say 5 and 7. That finishes off the union of A and B. the intersection of A and B, well, that would just be the things that they have in common. And it looks like the only thing that they have in common is 3. The complement of A, so that would be everything that's in the universal set that's not in A. Well, if A has 3, 5, and 7, that means we want everything else. 2, 4, and 6. So we'll write those down. 2, 4, and 6. That's A prime, or the complement of A. But we can kind of treat this like maybe algebra with order of operations. So here we've got a set of parentheses. We need to do that first. We want the intersection, the things that they have in common between the universal set and the complement of the null set. So the complement of the null set, everything that's not in the null set that's in the universal set. Well, that would be everything. So the intersection of the universal set and the universal set would just be the universal set. And then the union of that with B. Well, see, B has 1, 2, and 3. 1 is actually not part of the universal set, so we'll have to include that. So we'll just go ahead and say 1, 2, 3. I'm going to go ahead and say ... 7. And yes, I'm going to say that's okay. All right, that's it for Unit R, Review of Foundational Concepts, Lesson